what you're dealing with is you have a specific isotope, and you are going to shoot something at it with the concept of a nuclear bomb is very widely known. Now, how to design it is a little bit, more classified. But basically what happens is you shoot a subatomic particle. Sometimes it's a little barium, sometimes it's a number of different things. But basically, you're shooting a neutron at this atom, and you have enough of these radioactive atoms where basically it creates a pileup. So like if you ever see a really big pileup on the highway where everybody hits each other, that's kind of what happens. And as the energy expands, it keeps expanding, keeps expanding, keeps expanding. And that was some of those nuclear tests that were in that video from yesterday. You see what happens. It's an instantaneous bright flash, and it's an unbelievable amount of energy that's released. Now we have a different type of bomb that causes an implosion. Okay, but those were fission. Okay, which is a nuclear reaction. You're splitting. Okay?
Isn't fusion like 10 times stronger than fission?
It depends on how they do it, and it depends on how much fissile material they have, and that's basically the plutonium or the uranium or whatever it is. So when we look, you have new elements that are going to be formed from that. Okay, so you have fusion, you have fission, and you have nuclear decay. Okay, so all three of these kind of go together. And so all three of these are going to kind of go together, and they kind of go through and look at our some of our concerns. Okay, so you actually have nuclear material in your house. Okay, and a few years ago, I'll tell you this story real quick. A few years ago, there was a kid that went and bought, I'll give you a hint, it's in your your smoke detectors. Okay, americium, named after America. I can't ever pronounce it right, but it's a radioactive element. There's a small amount of it in fire smoke detectors. Okay, so this kid went and bought a whole bunch of these and was trying to do something like in his backyard, and someone called the cops or the FBI or what, maybe it's the ATF, I don't know. Anyway, they're like, this idiot's got some radioactive stuff in his backyard, and that's frowned upon. But this stuff is everywhere. Fusion, okay, we talked about tritium, deuterium, and helium. Fusion, what that happens basically is you have, and I'll check the chat in 1 second. I see there's like 4 chats. You have 4 hydrogens, okay, and you're going to shove those hydrogens really hard, kind of like making a diamond under intense heat and intense pressure. And when it creates a helium, it's going to release a whole bunch of energy. Okay, and so fusion, if you could find a way to do, and they're getting closer, but it's for a long time been looked at as impossible from a nuclear physics standpoint. If you could find a way to fuse atoms together without having to input a whole lot of heat, called cold fusion, you're looking at basically free energy, and you're looking at all the money in the world that you could ever use. Okay,
I don't know how they're gonna make that work.
Nor do I. And if we figure it out, I'll listen. If you figure it out, I'll be your manager. I only need like $1 million a year. I don't even, I'll just answer the phones. It's no problem. All right. So the sun is an unbelievable fusion energy, a fusion engine basically. And so without fusion, we wouldn't have what we have. So basically you have stuff come together, and everything has its own gravity, so it starts to conglomerate, it starts to come together, it starts to really, really, really press on itself, and then it basically like ignites, and that's where we get uh, stars from. Okay, so pretty cool. Um, and it takes I think it's 8 minutes. It takes light and heat and energy to get from the sun to the earth. So realistically, the sun could have just blown up and we wouldn't know it for another 7 minutes. Now, we don't think that's going to happen for another billion years or so. We won't be around then, but um, it's pretty interesting to see how some of this stuff happens. All right. Now, controlled nuclear fusion. Um, Chris, we're going to talk about that. There are two different types of radiation. There's ionizing and non-ionizing. So we'll actually talk about that here in a minute. But um, controlled nuclear fusion is, like we said, the holy grail of clean energy. Okay, it's going to be environmentally clean. Okay, you're not going to mysteriously, as a country, start to produce uranium and plutonium that can not be used in a bomb like Iran is doing, like North Korea did, like a number of other places. Okay, and then you can instantaneously shut fusion down. You hit a button and it's done. Okay, if fission is very problematic because if it gets out of control, it goes on by itself. Okay, and that's what happened at Chernobyl. They tried to shut it down, and the instance they had these rods that they stuck in there that actually made it worse. Okay, so it's not reasonable on Earth. Doesn't work quite yet. So it's going to be something that is going to happen hopefully in the future. Okay, so fission, check it out. Um, it's just like breaking in if you play pool. Okay, you have one subatomic particle that's going to hit a whole bunch of other ones. Okay, and then what it causes is a chain reaction. Okay, and it's called the neutron bullet. It took them a while to figure out how to do it. It's a cool little device. If you look, it's a silvery little device, and it's basically like if you have a bullet, it's basically like the primer of the bullet, where you hit it and it causes this to basically happen. So we understand it, um, and um, and it is very beneficial for us. We use it for a lot of things. The problem is sometimes it can get out of whack um, despite our safety precautions and things like that. So this is what happens. Okay, in this case they're using uranium as the fissible material. Okay, and so you shoot a neutron at it. What causes it to do is it causes it to very rapidly decay. It causes instability. Okay, and then you have uh, krypton and barium. Okay, I mentioned barium, and it basically splitting, and it causes more splits and more splits and more splits, and it creates that. So if you control this, it is a very, very, very impactful energy source. Okay, all they really do is they cause this reaction to happen, and they stick it in water, and it heats the water up, and the steam makes energy. Okay, but what you can see is that some elements, okay, if you do it in a lab, okay, a particle accelerator or something like that, or even a centrifuge that causes things to spin really fast, is going to allow some elements to undergo fission. So you can shoot stuff at them and kind of create new things, or split them and make slightly different behaving atoms. So it's pretty cool. Yep. So this is actually how we basically those elements on the bottom of the periodic table that I said we're not sure about. This is how they created them. They created them in a lab, shooting things into them and making them only very temporarily. So it's kind of cool. Nuclear energy, it is unbelievably expensive to start a nuclear power plant. That's why a brand new one hadn't been started until a few years ago in Georgia, and they ended up bankrupting themselves. Westinghouse had been around for like 100 and however many years. It takes billions with a B to get a brand new one of these started, and that's why there's not a whole lot of demand for it. Once you get it, it's great. However, it takes a lot of startup for it.
You'd
Okay.
have to think about some of the strongest materials in the world, or withholding one of the world's most deadliest substances.
Yeah. So, and that they don't have it. It's not going full nuclear. It's a controlled fission, but at the same time, it's a very delicate thing that people are using. So the chain reaction for nuclear, okay, is it just is just not vibranium. That doesn't really exist. Titanium, though, titanium is been used in spy planes and a lot of things like that in the past. But um, the fact is, these things are just uncontrollable. The amount of power, the amount of force. They detonated several bombs in Los Alamos. Okay, so if you look at, let me pull up a map real quick with this stupid thing. There we go. So if we look at Los Alamos, where that is, okay, where they did a lot of the bomb testing, okay, here it is. Okay, and you can look at where it is, and you still can't really look directly at like the what you call it, at the like sites and things like that. But so here's Los Alamos. They blew up a bomb right here that they felt the vibrations of in California. Think about that. So they felt the vibrations. They thought it was an earthquake in some of the bombs that they tested over here, hundreds of miles away. Okay, it's it's you're right. It's a lot, and it's kind of scary, but it's one of those things that's like a horror movie. It's scarier than heck, but you kind of want to watch it anyway. Okay, so it's pretty cool. Now, um, I think it was Chris said something about vibranium. We don't have vibranium, but we do have an element named after Thor. There's thorium. Okay. And nuclear energy relies on both of those. Okay. Because when uranium breaks down, it breaks down into thorium and et cetera. But what you're looking at is basically you have a reactor. Okay. And you have water basically being pumped in. Okay. And what happens is it creates steam, which turns a turbine and basically makes electricity. Okay, so it's pretty interesting. If you go to Lake Norman, okay, where one of the nuclear power plants is, half the lake, and we're talking about a big lake, half of the lake is about 70 degrees year round. If you think about it, that's pretty crazy. Okay, and so the fish hang out. They're like, ooh, warm water. It's like a jacuzzi. So when my dad and I used to fish, there are little spots where you can go, and the fish are like, ah, and they never bit our. We weren't very good at fishing, but that's kind of the setup here. Okay, um, when you look, here's reactor number 4 in Chernobyl before they covered it up. Don't laugh at that. It was very sad. We would be out there for hours and not catch a thing, and we literally look at the fish finder
It's
and they
messed up.
look it up at us. And we'd see them, the fish radar, we'd see them, they'd see us. Like, nah, bro, we ain't eating.
We ain't
So,
touching that.
yeah, we ain't eating that. So, what we're looking at is um, no air pollution, a lot of energy, okay, and we're not using fossil fuels. The problem is we don't have anywhere to stick it. So a lot of times people are burying it. A lot of times, it's very difficult to get rid of, and you got to keep updating it because it erodes through the metal and the concrete that they use. Okay, and so it's beneficial, but there's pros and cons to it. Okay. Um, so that's what we're looking at with that. Now, next week, we are going to talk about half-life, okay, and we are going to talk about nuclear decay a little bit more, okay. So we're going to really be using, the information that we know about subatomic particles, protons and neutrons, okay, to determine how things basically release radiation. Okay, so we'll be talking about that. There's a number of videos. Here's what Chernobyl looks like kind of a little bit today. Um, they've literally dug millions of tons of soil up and buried it in like containers and or put covered things up and put soil on top of it or cement and all kinds of stuff. It's pretty crazy. But you're going to go through, and the important thing for us to do is to make sure that we're caught up on our stuff. Okay, so I gave you some time yesterday. I'm giving you some time today to do that. But the first thing you need to make sure you do is the Unit 1 quiz. Okay, when you click on that, it'll take you there. You'll be able to take it. It won't take very long. You will need your periodic table, but it's a small grade. So, it's something where I can legitimately look at and see what we need to work on some more. And then, like I said, on Monday, we will talk a little bit more about decay, and we're also going to talk about half-life, okay, which I think is a video game or something. I don't really play video games anymore, but we'll go through and talk a lot about that. And then we're also going to look at a few more examples of nuclear stuff and maybe talk a little bit more about some of the things we've been dealing with. All right. So that's what we've got. I will be available for questions. I am basically going to be grading a lot of y'all stuff that you have turned in to make sure that we have a decent idea of where we stand in our notebook checks or our stuff that goes straight to Power School. Okay. Let me know if you need anything, and I will be here. Let's go.